For this lesson, we will be talking about the law of sines and how to derive from its equation. So, the law of sines states that the sine of an angle divided by the length of its opposite side is the same for all three angles of a triangle. The main equation that's used in the law of sines that we derive from is sine A for angle A divided by the side of A equals sine of angle B over side B equals sine of angle C over side of C. This is the equation that we'll be using when we're solving for any side or angle of a triangle. So let's make a new triangle over here, and let's add in the height of the triangle. So, as we've already learned previously from trigonometry, if we were to solve for, let's say, side B, we will use one of sine, cosine, or tangent. So, if we were given, let's say, angle A, to solve for side B, we will be using sine. So we would do sine A equals opposite of angle A, which would be h to the hypotenuse, so B. And this equation would give you the side of B. So then if we were to try and find side A given angle B, we would do the same thing using sine, where sine B equals the opposite of angle B, which would be h, because it needs to be a right angle. So it would be h over the hypotenuse, which in this case would be side A. Okay, so taking these two equations, now we want them to equal each other. So to make them equate to each other, we want both sides to be equal to h. And so how to do that is we want to multiply for this one. We want to multiply b to both sides to get h equals side b times sine of angle A. And for this side, we want to multiply both sides by side A to get h equals side A multiplied by sine of angle B. Now, since both of them equal h, they both equal each other. So the new equation is side B times sine of angle A equals side A times sine of angle B. Now this equation that we got is equivalent to saying sine of angle A over side A equals sine of angle B over side B, because if you take these equations, this equation right here, and you divide side B and side A to the opposite side, this is the equation that you're left with. Now, as we recall, the law of sines full equation is sine of angle A over side A equals sine of angle B over side B equals sine of angle C over sine C. Everything we've just done could be repeated using angle A and angle C, or angle B and angle C, to get the same result. This law of sines equation that we've come up with will be used when we're solving in the angle or side given angle, and a side, or an angle, side, and angle, or even side, and an angle.
We're going to be focusing on today during this part of the lesson is angle, side, angle, or ASA. This case means that if you're giving two angles and a side of any triangle, you can use the law of sines equation to find the other angle and other two sides of that triangle. This case holds true because if you were given two angles, angle A and angle B for example, and a side, say side A, you can find angle C, side B, and side C. Angle A and angle B would give you these two. Side A would give you this. Then you could solve for side B by setting up a proportion and just using algebra. You already know sine C because And angle A plus 180 minus angle A plus angle B will give you angle C. And that's just basic geometry. Therefore, you can use another proportion using angle C, angle B, side B, the side that you found from the proportion with angle A and side A, to solve for angle C. The angle side angle case is really just using this equation down here along with two given angles and a given side, and just using basic algebra to solve for your unknown sides and angles. The angle side angle theorem, or case, is easier to understand when numbers are being used with it in real examples, so we'll do an example on the next page. In this triangle, we have angle A, which is 32 degrees, angle B, which is 47 degrees, and side C, which is 21 units. These are two angles and a side, so that we know we can use angle side angle to find side A, angle C, and side B. We can easily find angle C by adding angle A and angle B together and subtracting 180 by that sum. We can find side A and side B using the law of sines equation. The first step in solving a problem like this is to write out the law of sines equation. The first thing we need to do is solve for angle C using angle A and angle B in what we know about triangles. Angle A is 32 degrees and angle B is 47 degrees. 32 plus 47 is 79. We know the total sum of all the angles in a triangle equal 180 degrees, and that minus 79 gives you 101. Therefore, angle C equals 101 degrees. We can now write 101 in our little triangle diagram. The next thing we need to do is use this side of the equation. Using that equation, we get the sine of 47 over B equals the sine of 101 over 21. We can then cross multiply to get B sine 101 is equal to 21 sine 47. We can then divide both sides by sine 101 to get B equals 21 sine 47 divided by sine 101. And if we plug all that into our calculator and make sure you're in degree mode, not radian mode, you should get a side measure of B equals 15.6459. The next part of this equation should be to set this part of the equation equal to this part of the equation and isolate and solve for the length of A. I'll go ahead and write the B value on the triangle. I'll just write 0.65 because I can't fit it all in there, and I'll delete the rest of the work. Alright, now moving on, we have the sine of angle 32, angle A, which is 32, over side length A, which we don't know, is equal to the sine of angle C, which is equal to 101, over side length C, which is 21. After we cross multiply, we get A sine 101 equals 21 sine 32. If we divide both sides by sine 101, we get A equals 21 sine 32 divided by sine 101. If we put this into our calculator, we get A is equal to a side length of about 11.3366. These are the final answers to the problem, just in case you couldn't make out my awful handwriting on the board. The cool thing about law of sines is that you could check your answers to make sure they're right. So, for example, in this problem, you would do sine 32, which was angle A, over side A, which we found was 11.3366, is equal to sine 47, which is angle B, over side B, which we found was 15.6459, is equal to sine 101, which is angle C, over side C, which is 21. And you could solve each single proportion, and for this proportion, if you divide sine 32 by 11.3766, you get 0.0467. You also get that same exact answer for sine 47 divided by 15.6459, and you get that same answer for sine 101 divided by 21. Therefore, you know your answer is probably right if all the proportions are equal to each other. That's it for angle side angle. If you have any questions, I'll stop the video and you could please ask now.
For this part of the video, we'll be focusing on using the law of sines when given a triangle with two angles and a side in an angle side pattern. So you can fill in the corresponding variables from the triangle into the law of sines equation. For the triangle above, you can plug in angle A here, angle B here, and side A here. This will leave you with finding side B, angle C, and side C. In order to fully solve this triangle, you could first find angle C by subtracting the sum of A and B from 180. You can find side B by plugging in these three variables and then cross multiplying and then dividing both sides by sine of A. Since it's best to use your known variables, you should use this part of the equation with this one when you're trying to find this side. So plug in angle A, side A, and angle C, which is what you found before, and then you cross multiply and divide both sides by sine of A, and that will give you C. And that should complete the whole triangle. Now let's look at an example using the law of sines given the angle side pattern. First, we could find the measure of angle C by subtracting the sum of angle A and angle B from 180. You should then get 16 degrees for the measure of angle C. Next, you can use the law of sines to find side length B. So sine of angle A, which is 81 degrees, over side A, which is 9, equals sine of angle B, which is 83 degrees, over side length B. Then cross multiply. And divide both sides by sine of 81 degrees. And this should give you B equals 9 sine 83 over sine 81. And after plugging this into your calculator, you should get that B equals 9.044. Next, we could solve for side length C. So sine of 81, which is angle A, over 9, which is side A, equals sine of angle C, which is 16, over side length C. Then cross multiply. Get C sine of 81 equals 9 sine 16. Then divide both sides by sine 81. And this should give you C equals 9 sine 16 over sine 81. Plug this into your calculator and you should get about 2.512. Now that you've solved all parts of the triangle, you could plug it into the missing places. Finally, here are all the missing variables and sides. Finally, here is your completed triangle with all the missing sides and angles filled in. The last part of our video will be on something called the ambiguous case. This case occurs when the given angle in a triangle is opposite of one of the two given sides so that it's not an included angle in a side-side angle pattern, also known as SSA. In this case, there may be one, two, or no triangles that satisfy the given conditions. Next, I will show you how you can determine the number of triangles that can be satisfied during the ambiguous case. As you can see here, we are given angle A, side little b, and side little a in a triangle, which is written in red. This shows that we have the ambiguous case because we're given two sides and then an angle, or an SSA pattern. You can see that side A is not drawn all the way because we're not totally certain that the given conditions can actually make a triangle. We could also draw in the height of the triangle H. This will give you a right triangle on the left, so that side little b is the hypotenuse, H becomes a side, and A is one angle. As you know from trigonometry, the sine of a given angle theta equals the opposite side over the hypotenuse in a right triangle. This makes the sine of A, angle A, equal to the height, or H, over the hypotenuse, which is B, for this triangle. Then we can derive an equation to solve for the height in terms of A and little b. Once we find the value of h, this can help us figure out how many triangles there are, if any. The rules for the ambiguous case are as follows. If little a is less than the height we determined h, there is no triangle that can be satisfied to fit the given conditions. This tells us that if side A is too short, it won't be able to form a triangle because it can't reach side C, like in this triangle. We can draw a circle with a radius little a to show this. As you can see, the radius will never come into contact with the side C, no matter the angle. Now, if little a equals h, then the given conditions can only make one triangle. And this gives us the right triangle because little a is the height. Side A will then hit side C at exactly 1 point, and it'll be too short to hit anywhere else on side C if you change the angle. We can draw another circle with radius little a to show this is true. If little a is greater than little b, then the given conditions can also only make one triangle. If we were to rotate side A around its fixed point at C, the end of little a will only ever hit the side little c at 1 point, which is B. Also, if little a equals little b, then one triangle would be formed again. The triangle formed will then be an isosceles triangle because the two sides are congruent. Again, we can draw a circle with radius little a around both of these triangles to see that this is true. Finally, we have the last situation, which is when little a is greater than the height h, but less than little b. This results in two possible triangles. As you can see, there's one triangle where angle B is acute, this one, the bigger one, and then one triangle where angle B would be, this is angle B, where angle B would be obtuse. So we can draw another circle with radius little a again to see that the circle will touch the side in two places. Keep in mind that when we do these types of problems, we have to find the triangle with the acute angle first, because when we use the inverse sine function in the graphing calculator, the calculator will only give us the value for the acute angle, not the obtuse one. So watch out for that. Now we can move on to an example. This problem asks us to solve triangle ABC, which means to find all the missing angles and sides. Here they give us that side A equals 6, B equals 7, and angle A equals 30 degrees, which we can label in a triangle. And in this problem, we are trying to find angle A, angle B, and side C. First, we should check to see how many triangles can be formed with the given information. We can use little b times sine of angle A to find the height. So 7 times sine of 30 degrees equals h. And after evaluating this, you get h equals 3.5. Then you can use this number to compare to A and B. Then you can order the letters from least to greatest. So it would be H is less than A is less than 7. Oh wait, B. This tells us that two possible triangles can fit the given information. So first we'll find angle B of this triangle. Oh wait, this is angle B too. Of the bigger triangle, because that's the acute angle. And you can use law of sines to find the angle. So sine of angle A, which is 30 degrees, over little a, which is 6 equals sine of B over little b, which is 7. Then we solve the equation for b. So multiply both sides by 7. And then use the inverse sine function to find b. So inverse sine of 7 sine 30 over 6 equals b. And evaluate. You should get that the measure of angle B is 35.7 degrees. Next, we'll find the measure of angle C by subtracting angle A and plus angle B from 180. So 180 minus 30 minus 35.7. And you should get 114.3 degrees for the measure of angle C. Now you can find the length of side C, so using the law of sines. So sine of 30 degrees over 6 equals sine of 114.3 degrees, which is angle C, over little c. And then cross multiply and get this. And then divide both sides by sine 30. And get C equals 6 sine 114.3 degrees over sine 30. And after evaluating, you should get that C is about 10.94. And here are all the missing sides and angles when you assume that angle B is acute. But we're not done yet, because we have only solved the angles and sides so far, assuming that angle B was acute. Now we have to assume angle B is obtuse for the second possible triangle. Since we already found the acute angle B for the first triangle, which was 35.7 degrees, we can use that and subtract it from 180 to get the obtuse angle B. And this comes out to be 144.3 degrees. And to find angle C, all we do is subtract both of the angles we have right now from 180. So 180 minus 30, which is angle A, minus 144.3, which is angle B. And this gives you 5.7 degrees. Then we could use the law of sines again to find the length of side C. So sine of 30, which is angle A, over 6, which is side A, equals sine of 5.7 degrees, which is angle C over little c, and then cross multiply. And then divide by sine 30. This gives you C equals 6 sine 5.7 degrees over sine of 30 degrees. And after putting this into your calculator, you should get C equals 1.19. And at the end, this is what your triangle should look like for assuming angle B is obtuse. And I think that's it. Thanks, folks.